chemistry class. I hope you are all doing good and ready for our class. Now, in last class, we were learning about compounds, elements. Then just we entered into mixtures. Then we have learned the difference between pure and impure substances. Now, in today's class, we are going to see about the formation of mixtures. Actually, what's a mixture? It's a combination of elements, compounds, or both elements, compounds. Here in mixtures, it will be physically mixed and the chemical composition will not vary. This is called mixture. How these mixtures are formed? How we can form these mixtures? That is, we are going to learn in this formation of mixtures. In formation of mixtures, in 6 types we are going to learn how we can form this mixture. The first one is solid-solid. From the name even you can say what is the solid-solid mixture. You take a mixture of 2 solids. For example, sand and sugar, sugar and salt, like this. When you mix 2 solids, it is called solid-solid mixture. Now we have formed a solid-solid mixture. One more example is rice and stone. We have stone in the rice, right? This mixture is also called solid-solid mixture. Then the next one is solid-liquid mixture. One item should be a solid and other should be a liquid. Can you say example? Yeah, very good. Sugar in water, salt in water are the examples for this solid liquid mixture. Then the next one is solid gas mixture. Can you guess an example for this solid gas mixture? Solid should be there, gas should be there. Smoke. We all know smoke, right? Smoke is something gas, but small dust particle will be suspended in the smoke. So, solid, the dust particles are solid and gas. They are called solid gas mixture. Next one is liquid. 2 liquids you have to add to form a mixture. How you can form? Can you say an example? Yeah, water and alcohol can be mixed together to form this liquid mixture. Next is gas and liquid. Liquid should be there, gas should be there. What's the example? Liquid and gas example, consider a soft drink like Coca-Cola, Fanta, Spirit. We know the soft drinks, right? When you open the cap of this bottles containing the soft drinks, what happens? As soon as you open the bottle, a gas comes out, right? What is that gas? Carbon dioxide. So, in the bottle, it is present with the liquid we drink. The juice we drink is present with that gas. It is called liquid gas mixture. Next one is last, gas and gas mixture. Everyone can say this example. Come on, try to say the example for gas and gas mixture. Gas and gas mixture example is the atmospheric air. The atmospheric air has many gases like hydrogen, oxygen, nitrogen, carbon dioxide, methane, etc. This air contains a mixture of many gases, right? So it is called gas and gas mixture. So clear about this formation of mixtures. What are the 6 ways we can form the mixture? Solid and solid, solid and liquid, solid and gas, liquid, gas, liquid, and the last one is gas and gas. Clear about this formation of mixtures? Next one is types of mixtures. You all know from grade 6 to 6, 7 till we have the same topic. So we all know about the types of mixtures. How many types of mixtures we have? Yeah, very good. 2 types of mixtures. What are they? Homogeneous mixtures and heterogeneous mixtures. What is a homogeneous mixture? Or what is the difference between this homogeneous and heterogeneous mixtures? In homogeneous mixtures, 2 or 3 particles are mixed. And in homogeneous also, the particles or 2 or more state of elements are mixed together physically. What is the difference between these two? Consider you have sugar and water. You are putting this sugar in the water. What happens to the sugar? It dissolves completely in water. In the other hand, you take some chalk powder and you put it in the water. What happens to this? Whether this chalk powder will dissolve in the water? No, right? So, what is the difference between this homogeneous and heterogeneous mixture means? The homogeneous mixture, it dissolves completely and we cannot see the particles after dissolving, and the distribution will be uniform. But in heterogeneous mixtures, after dissolving the particles we can see, and the distribution is also not uniform. Now we can learn first about this homogeneous mixtures. Homogeneous mixtures, as I said, the components in the mixtures dissolves completely and invisible, and the distribution is uniform. We can see this homogeneous mixtures in 2 types. What are they? Solution and alloy. What is a solution? When you hear this word solution, what do you remember? Yeah, solution means a solvent should be there and solutes should be there. Consider, for example, the same example, salt or sugar in water. You take sugar. What is that sugar? Sugar is a solute and the water is a solvent. When you add this sugar, it dissolves completely and we cannot see it by the particles or the components after dissolving. We cannot see by our eyes. It is an example for solution. Next is alloy. Alloy means there should be a metal. This metal should mix with some other metal or non-metal to form an alloy. This also comes under this homogeneous mixtures. For example, when you consider the stainless steel, it has iron and carbon, whereas this iron is a metal and carbon is a non-metal. Here, nichrome. Nichrome, how it is formed? It's a mixture of nickel and chromium. So, clear about what is a solution and alloy? Homogeneous mixtures means the components are not visible after mixing and they are uniform in distribution. They are divided into 2 types, solution and alloy. Solution, for example, solution example, salt in water or sugar in water. Then alloy is a mixture of a non-metal and a metal or non-metal. A metal should be there, one should be a metal. With this metal, other metal or other non-metal can combine to form mixture. So, example, stainless steel. It's an alloy of iron and carbon. One more example, nichrome. It's an alloy of nickel and chromium. Clear about homogeneous mixtures? Next one is heterogeneous mixtures. What's an heterogeneous mixture? It's an opposite of homogeneous mixtures. In homogeneous mixtures, the components are uniformly distributed Whereas in heterogeneous mixture, the components are distributed in an uniform manner. Then the components are visible. Here the components are not visible. Commonly we divide this heterogeneous mixtures into two types. They are, what are the two types? Yeah, suspension and colloids. There we have divided homogeneous mixtures into solution and one more. What is the other type of homogeneous mixture? Solution and alloy. Here heterogeneous mixture is divided into two types. They are suspension and colloids. What's a suspension? From the name even you can say what is a suspension. What's a suspension? Yeah, suspension means something will be suspended in some. For example, consider chalk piece. You have a chalk piece. You grind the chalk piece into powder and put it in a glass of water. What happens? What happens to the chalk powder? You add to this water. It will float or it will suspend somewhere in that liquid. When you allow the setup for some time without any disturbance, you are keeping that a cup of glass with chalk powder in a place. You are not disturbing that. What will happen to that? What happens to that mixture? The chalk powder will start settling in the bottom. So this is called suspension. When the chalk powder suspends in that liquid, that mixture is called suspension. But the distribution is not uniform. Why? When you allow this mixture for some time, it will settle down. Now you see, this area has the chalk powder, but this area does not have the chalk powder. So this distribution of components is not uniform in homogeneous mixtures. Then the second type of heterogeneous mixtures is colloids. When you see these colloids, they are the type of heterogeneous mixtures. They have two things. What are they? One is dispersed phase, other is dispersion medium. These two items combines to form a colloid. This colloid, or although it is a heterogeneous mixture, it can be a homogeneous mixture also. When it is a homogeneous mixture, why we are saying it is a homogeneous mixture means sometimes the particles are invisible. In colloids, sometimes the particles or the components are completely dissolved. We cannot see that particles with our eyes. So they come under homogeneous mixtures also. Actually, it is a heterogeneous mixture. In colloids, one more thing is the particles will be very small, very small. Then the example, one of the example, best example for this colloids is emulsion. What is an emulsion? Have you heard this word emulsion? You are all familiar with this word emulsion. What's an emulsion? Emulsion means it's a mixture of two immiscible liquids. What is that? It's a mixture of two immiscible liquids. I have said the word immiscible. What is this immiscible? Consider two liquids. When you add the two liquids, it will mix, right? But immiscible liquids means both the liquids will not mix together. They are called immiscible liquids. For example, water you are having. When you add kerosene or oil to this water, they both are liquids. Even though they both are liquids, they won't mix together. They are called immiscible liquids. the mixture of invisible liquids are called emulsion. Emulsion is an example for colloid. So emulsion is a colloid. Clear about what is a colloid and what is a suspension? Suspension example, chalk powder in water, whereas the colloid example, liquid, that is water and oil mixture. So what are the things you have learned today about the formation of mixture? Solid, 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 liquid, solid gas, liquid, liquid, liquid gas, gas, gas. In 6 ways we can form this mixture we have learned. Then we have learned about the types of mixtures also. The two types of mixtures are homogeneous and heterogeneous mixtures. Homogeneous mixtures are again classified into solution envelope, and heterogeneous mixtures are again classified into colloids and suspension. We all know that what is homogeneous mixture and what is heterogeneous mixture. The mixture that the distribution of the component is uniform in homogeneous and not uniform in heterogeneous, and the components are visible in heterogeneous and invisible in homogeneous. And solution, about solution you know, example sugar and water. Then the alloy means it's a mixture of metal with non-metal or metal. Example, stainless steel is an alloy of iron and carbon. And also another example, nichrome is an alloy of nickel and chromium. Then the next one is heterogeneous mixtures. In heterogeneous mixtures, what we have learned, the two types, suspension and colloids. Suspension example, chalk powder in water, and the colloidal solution example, emulsion. What's emulsion? Emulsion is a mixture of immiscible liquids. Any two immiscible liquids like water and kerosene, water and oil. These are the immiscible liquids, mixture of immiscible liquids. So it's an example for colloids. By this we can end today's class. In the next class, what we are going to learn? In the next class, we will learn about the separation technique. Mixture, how we can form mixture? Solid, 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 liquid, liquid, liquid. Like this we can form mixture. Now, in the next class, we can learn about separation techniques. Separation techniques deals with how we can separate the components from the mixture. The mixture may have many components. How we can separate all these components from the mixture? For example, you have rice and stone. How we can separate the stone from the rice? By picking using our hands. Like this, we can learn about many techniques like sieving, distillation. There are many techniques we have to separate all types of mixtures. Like for example, solid-solid mixture we have different technique. Then solid-liquid mixture we have different technique. Liquid-liquid mixture we have different techniques. Like this, different techniques can be used to separate the components from a mixture. About that we can learn in the next class. So, you have to read today's question and get ready for the